So we have these two bodies of the same mass. So this is M and this is M, traveling in the same direction. X has a speed of 5 meters per second and Y has a speed of 2 meters per second. So object X is going to catch up to and collide with the 2 meter per second object. Oh, X collides with Y. The objects collide but do not stick together. So that must require, if they don't stick together, that when this one hits this one, object Y must move off with a greater speed than X had. Otherwise, X can't have a greater speed than Y, otherwise they stay together. And it will eventually have the same speed. So the only option is that X collides with Y and Y moves off at a greater speed. Which predictions about the center of mass of the two systems immediately after the collision? Well, what we know right now is that we can treat this whole thing as a system. We can treat it as a system that has a center of mass, which would be located at the midpoint, and that center of mass has some velocity v. It is not 5 and it is not 2. And that center of mass will maintain that velocity because of the law of inertia. A body wants to keep its current velocity. A system wants to keep its current velocity, and that system has a velocity v. So the center of mass does not move. That is false. The velocity of the center of mass does not change, and that sounds right. Center of the mass decreases? No. Center of the mass increases? No. Choice B. It is the momentum of the mass of the system which can be substituted for and represented as a center of mass that is conserved.